Okay, so we are going to use Logic's binaural panning function. If you were to switch to mixing completely in binaural mode, you would massively expand the possibilities of the stereo depth that you can achieve. And what's being measured is how your ear responds to frequency over certain distances and at certain angles of incidence. So at 90 degrees away from the front of your head or 180 degrees, all those measurements are taken and are plotted and turned into effectively a computer program which will allow a response to be generated when you say, okay, I want 2 kilohertz to be reproduced at 90-degree angle. It will simulate the front and the back and the left and the right. So that's the interesting thing about it. You can get this apparent 360-degree spectrum, whereas stereo can only really deliver left or right. It can't really deliver apparent forward or backwards motion. So here we go. So I've just recorded a little kalimba that I've got, and I'm going to play that on a loop in a minute, and then we're going to play it through the binaural mode on Logic. So Logic defaults to stereo out mode, but if you click on that, you'll see that you get binaural panning as an option. So we turn that on, and I'm just going to set this going. So let's just press play. Let's go into this. So as you can see, some of those positions on the circle, we're in the center of that circle, and basically when the dot is in the position that I've got it now, that is behind us at that right hand position. So it's using frequency curves to actually simulate what's the difference between front and back. In general, the front tends to sound a little bit brighter than the back sound. So it's a kind of, it's using EQ and delays and phase response as well as the intensity differences. Everything is in there at the same time. If I play it again, you can see if I move it around much quicker, you can hear it very clearly moving around this kind of three-dimensional space. There's also an effect called the Doppler effect that you'll have heard when an ambulance or a police car goes past. That's a kind of delay that's happening in the sound. I'll put a link to the full explanation of the Doppler effect in the notes. Let's just play it with this on. So the Doppler effect starts to affect the perceived frequency of the sound due to the speed of sound in reality, but the binaural effect there is reproducing it using an algorithm. And we can increase the size of the space. So it's really interesting. You get a much more expanded palette to play with. Um, if you do use it in your mix, you have to bus it in a certain way. What you'd have to do is, instead of outputting it through stereo output, you would have to output it through a bus, and that bus can then go to the stereo output. But before it, Logic gives you a particular binaural post-processing plugin, and that sits on the bus and basically doesn't do anything other than to select a particular type of listening mode. So if you're mixing on speakers, you would select speakers. If you are listening on headphones, then you can select one of these options. And now in my headphones, that sounds a lot more, even more clear than it was before. If you played that on a set of monitors whilst we were on that headphone mode, it wouldn't sound quite as good on the monitors. So you'd have to switch to the monitors. And this is the fundamental problem with mixing in binaural. It very much depends how somebody's going to listen to it. And as there are going to be a variety of listening modes for any work that you put out commercially, a lot of people shy away from binaural unless they're absolutely sure that people are going to be listening on headphones. A lot of people listen to games on headphones, and that's why it tends to be used a little bit more widely in the gaming world.